Good afternoon and welcome to today's webinar. My name is Madeline Holzer. I'm the Education Events Specialist here at Zahn. I'd like to welcome you today to Zahn's Summer Sizzling New Product and Workflow Preview. Today we have Matt Viens. He is our High-Tech Training Supervisor at Zahn, and he's going to be walking me through those workflows. I do want to do a little housekeeping. Just keep in mind we do have our questions tab on the toolbar. In case you do have any questions during the programming, you can go ahead and put that in the questions tab, and we will address those questions at the end of our session if time does allow. Welcome, Matt.
Thank you very much, Madeline. Welcome everybody to today's session. I just wanted to go over, first kind of introduce myself and let you guys know who I am and what I'm going to be doing here for you guys today. So just kind of a brief background on myself. I started back with CAP back in 2010 and kind of gained my knowledge and experience through the digital side as well as the traditional lab workflows through CAP's production standpoint. And then from there, kind of went up through the ranks and started teaching and providing technical support and services for the digital equipment that we saw and we're handling in-house as well. In addition to that, I've also, I've traveled to many different labs, and I've been able to, introduce them into their digital equipment and train them on the different CAD softwares and mills, and just gained a wealth of knowledge, not just about the digital side, but also the lab side as well. So kind of helped me grow in my role and be able to provide an excellent type of service and support for these features. So where did I come from? I touched on this. Like I said, I came back from, I came from CAP, but then we were acquired by Zahn Dental in 2016, which allowed us to grow both as a small company and as a large company, being able to provide the services and support as well as the intricate knowledge and experiences that we've developed over the years to provide an excellent service and to help all of our customers thrive throughout the industry. So it was a really great beginning with CAP, and we've only seen it grow exponentially with the merger since 2016 with Zahn. And so I'm happy to continue on here, doing what we're doing and being able to provide the services that we do provide. So why am I here today? I just wanted to talk to you guys to let you guys know what new products that we have available and what different types of workflows that we also have available for some softwares and whatnot that we already currently see out there, but maybe new updates and features that they may have. So I wanted to kind of bring these to your attention so that you guys can see what is available to you and what's going to be new for the summer and what we can utilize that and how that can help our labs thrive throughout the whole process here. Okay, so with that, let's go ahead and touch on the first aspect, which is going to be EnvisionTEC. EnvisionTEC has a number of printers that are being brought into the dental field, specifically the D4K and the EnvisionOne printers. Along with that, they're also going to provide a light curing unit, which is the PCA 4000 that you see here on the screen. Now, the difference between the D4K and the EnvisionOne is really going to be the cost and the build platform size, but they're both going to be really well developed printers that allow us to go ahead and print at a very fast and accurate rate. Like I said, the build platforms are a little bit smaller on the D4K, but it doesn't mean that the build times are going to be any different because they both utilize the same type of technology that's going to be more efficient for the printing process that we see here. So they're both a DLP style printer. And then, like I said, with that and coupled with the light curing unit, it's going to be a great process to go ahead and infiltrate the printing market that we have here on the dental side, especially with all the new materials and different offerings. Digital dentures go into the printing process, so this is going to be something that's going to be really good with us. Going from there, we already know that EnvisionTEC had these printers, but they're going to be developing this new style of printing materials that we see here, which is we're going to see that more so with the E-AquaModel that we see here, but other materials down the line. So what makes the difference between these printing materials that you normally have, which is the resin materials that are available to us on the Envision printer, versus the E-AquaModel, is going to be the way that you're going to be post-processing these models. Now, the E-AquaModel is going to be one that's going to utilize, just like the name kind of infers there, water in the post-processing process, I guess you'd say. And so that's huge, because typically what we have going on now with resin printers is that you have to utilize an IPA style alcohol to go ahead and rid the excess material of any uncured resins or anything that's going to be sticking to or adhering to the model after the print is cured and after it's been finished. So in order to post-process that, like, you have to go ahead and run it through an IPA bath and allow that non-cured resin to go ahead and be dissolved by the IPA. Well, this kind of eliminates that and allows you to use just water to go ahead and go through the process of post-processing, which means it's less caustic. It's not going to be as hazardous. There's no toxic fumes that you have to deal with, and it's going to be a lot cheaper to run with. What's also great, though, is that coupled with this new process, they also allowed for this to kind of maintain the structural integrity of these prints. And so you're not losing any sort of values as far as accuracy or hardness within the model itself. Actually, if anything, I think it makes it a little bit harder, I think the specs say, but it's going to go ahead and continue to have that added strength that we've seen throughout, and allows us to have the benefits of the E-AquaModel, or the Aqua process, I guess you'd say. So with that said, there are different changes in the process and how we go about post-processing these models. There is a three-phase process that we're going to go through here. And this kind of identifies what the difference is between the traditional method and what the new process is. So with the first step that we see here, it's just going ahead and you're going to place the water into a plastic container and make sure it's at room temperature. Then you're going to go ahead and make sure that all the models are fully submerged into that container to ensure that the water is going to be encapsulating the model and making sure that all surfaces are going to be contacted with the water, so that we make sure that all uncured resins are going to be soluble within the water. We only leave it in there for about 30 seconds too, so it doesn't have to sit in there for quite as long as it would if you had a traditional IPA bath. Next, you're going to go ahead and you're going to clean lightly the units with an ultrasonic cleaner. So you're going to go ahead and take the bath that you had it sitting with, and you're going to take those models and put it into an ultrasonic cleaner. Again, you don't have to use IPA, you can just use regular water at this point. And it's about a 20-minute cycle you want to let it go through here. And so it's at this point that we want to raise the temperature of the water to ensure that the solubility of the resins is going to be accurate. So you go ahead and you place those units in ultrasonic cleaner. You preheat the water to 122 degrees Fahrenheit, and then you're going to go ahead and run the ultrasonic for about 15 minutes. After that, after the models have been run through the ultrasonic, we can go ahead and we can take the units back into the second plastic container, all right, which is at room temperature, so we don't have the same contamination that we had with the first bath. And you're going to fully submerge each model into there, and you're going to lightly brush it with a brush to ensure that any of the uncured resins are fully removed from the surface and that it's fully soluble in that water. So we've gone through the first part, the second part, and the third part. The first part was obviously just the initial bath to get the full bulk and kind of give a rough cleaning of the units inside of a lukewarm or room temperature bath. And then we've gone and we've done the second part, which was bringing it into the ultrasonic at a lot higher of a temperature, but that's just because we need to make sure that we're diluting or soluting the resins on the actual model itself. And then after that, we bring it back into the second bath, which is where we go ahead and any excess resin that's maintained onto the model at that point, we go ahead and we just agitate the models a little bit with a brush to ensure that we finally remove all aspects of that. So this is huge because the way that this is handled is a lot faster and a lot cleaner than the previous cycles that we had to do with resin printers. So previously you would have to take the prints and you'd have to let it sit into an IPA alcohol bath for about 20 minutes. After that, you'd have to do some light agitation just like we would with this one, but then you'd have to run it into a second IPA alcohol bath, which kind of makes it a little bit longer process. So we have about 40 minutes as opposed to a 20-minute and some odd second cycle that we have here. So there's a number of advantages of doing it this way and the advantages of the E-AquaModel coming into the market. And I touched on this a little bit earlier, But this was just kind of going through the process of not having that hazardous material, not having the toxic fumes that we have, and kind of bringing an element of going green into the office. You know, we no longer have to worry about the disposal of the IPA alcohol. We no longer have to worry about the caustic materials of the resin being spilled all over the place within conjunction to the IPA model. So you don't have to worry about the disposal, as I said about that, and it's more going to be regulated as far as the cleaning goes, because we have a water soluble unit, which is going to be a little bit more easy in handling in post-processing, I would think. So not only does going green also is a good aspect for our labs, right? We always want to go green and we always want to be helping the environment in that aspect. But typically, in this essence, the going green aspect allows us to save both time and money on the printing side, because it allows us to go ahead and take what we formerly had as a 40-minute process and shrink that down, both in the time size, but also in the money size, because we no longer have to pay for the excess amounts of IPA or the disposal of the IPA alcohol and the resin mixtures. So there's a lot of advantageous aspects to this E-AquaModel, which I think is going to be great for our industry and great for our particular workflows that we're going to be dealing with. Okay, and then on from there, I know that they also have some other materials in addition to the E-AquaModel coming out, where they just had cleared the denture base model and their high impact tooth materials as well, which I believe are both going to be utilizing this sort of aqua process as well, which is going to allow us to use that water soluble post-processing method, which again is just going to be a great process all the way through and through. So that was kind of the new materials that we had talked about. Let's go ahead and take a closer look at the workflows that we have coming to us. And one material that I really wanted to touch on today was a Millbox 2020. I know that we have a lot of customers that are either utilizing Millbox earlier versions or looking to upgrade to 2020, which is a great new program that we have, or update that we have for the Millbox software. So I kind of wanted to take a look and highlight the different features that we have for Millbox and go through that. Unfortunately, today I'm not going to be able to do a live demo on the Millbox software due to some technical issues, but we can go ahead and we can take a look at the different different processes and different attributes that does have and does allow us to go ahead and maximize our workflows, so that we can see how this is going to be effective in our current working conditions. So with that said, the first thing that I want to highlight is a big change that we have, which is the 90-degree milling process. So with this allows us to go ahead and take units that were previously just milled from either the top or bottom sides of our mills, and allows us to go ahead and nest them onto the edge of the unit, edge of the puck, so that we can go ahead and utilize the milling software or the milling capabilities to engage the facial aspects of our crowns. And this is huge because it's only available on certain mills that have the C clamping feature, and some of those mills that we can speak of are Roland, the 51D and the 52D and the 52DC and 52DCI. Those all have the capability to have the C clamp fixture kind of integrated into that mill, so we can go ahead and utilize this feature. Like I said, this feature allows us to go ahead and nest units like this bridge that we see on screen here at the edge of the face of the puck. And that allows us to go ahead and then we can rotate the puck and mill it on the facial surface. Since we know that the Roland mills are going to be having the spindle facing down, it's going to allow that to go ahead and engage in those areas that it otherwise wouldn't be able to do if you had the traditional style clamping system, or if you had anything else that was kind of preventing it from doing such, like a different angle or presentation of the spindle. So this is a great feature that allows us to go ahead and do that. And with this feature, we can not only just come in at a 90-degree angle, we can actually rotate back and forth up to 30 degrees. So it allows us to get into those interproximal areas that we aren't able to normally get into if we just milled from the typical 5+ or 5-axis or 3+2-axis milling process. So I really wanted to highlight this feature because it's a really good feature that allows us to go ahead and increase our overall accuracy of the mill and what we're going to be designing is and how it correlates with what is actually the final product after the mill. So this is a great new feature that I think is going to work leaps and bounds, and it's actually a relatively easy feature to use. But unfortunately, I'm not able to show you, but it is pretty simple in the fact that you just nest it all the way out to the edge, select a few options, and then highlight the areas that you would like to mill with this 90-degree option, and then it goes from there. The next thing that I wanted to talk about in Millbox 2020 was the connectors. So a big thing with connectors is that we always see them as being a stable and integral part of holding the unit into the puck. But sometimes they can really envelop areas that we don't want them to envelop, and it kind of prevents us from accurately milling those areas or having to post-process those areas to get them down to the perfect area that we had designed or had intended the unit to look like. Well, with the Millbox software, we do have several options that are available. Some of them have already been available to us in previous versions, where we go through the connector and we choose whether or not it's cuttable, it's semi-cuttable, or if it's left alone so that it's going to be permanently there. But other options that 2020 brings to the table is the ability to see the horizon line, which if you can look at the unit on here on the screen, you can kind of see around the connector, there's this white line. And that indicates the point at which the mill is going to flip from one side to the other side of the puck so that we can maximize the efficiency of the connector. So if we place the connector on this this milling line, this equator line, I guess you'd call it, that would allow us to go ahead and maximize the millable areas when the mill is going to be engaging that unit from the top and bottom sides. So it's minimizing the amount of area that the unit is going to be taking up and kind of reducing the area of effect as far as the outcome of the unit. In addition to that, you can also see on here, these are probably different looking connectors. So these are adaptable connectors. The adaptable connectors allow us to go ahead and create a connector that's no longer just a single straight rod that connects the unit to the working part, but we can go ahead and have it kind of flow or follow that horizon line and kind of really maximize the hold on the unit while at the same time minimizing the amount of impact that connector has on the overall dimensions or surface area of the unit. So we're maximizing the integrity of the holder, but we're not increasing the amount of surface area that's taking up on the unit, which is really great. So it allows us for a different type of holder that's not typically seen. And you can see here it's pretty cuttable as well. So it's going to be easy to remove. So it's a little bit flatter surface and it's going to be easier to mill and it's going to be stronger for holding. But at the same time, it's going to have less impact on the unit results at the end of the job as well. Another feature that has been really cool with Millbox 2020 is the ability to add barcode reading and barcode scanning. And this is a great feature for large labs that have high production rates, in which that we can go ahead and keep track of pucks in a very well inventoried and managed position, but also for quick acquisition on the pucks when we go through the milling process. As we can see here, this process kind of details all the individual steps that you need to take, but allows us to go ahead and select our block that we have. We can print a unique barcode identifier for that block, and then go ahead and print a label for it. That label is then affixed to the side of the puck with a 9mm printing label, and then from there we can go ahead and set up the settings and use the barcode that's been applied to that puck and use it for searching later on when we're going to want to go back and to use that puck again, or if we wanted to go ahead and cipher for different types of inventory controls, you can go ahead and read those barcodes accordingly. The barcode is going to go ahead and give all the unique identifiers that are going to be found in the job name itself or in the stock name, which you can see here pointed out in the slide. And then these are the settings that we have to go ahead and adjust those individual barcodes. The last the last thing that I wanted to touch on with Millbox 2020 was going to be this new feature that allows us to go ahead and use a thickness map while we're doing our milling process. The thickness map allows us to go ahead and control the amount of thickness that we see on units and allows us to see if there's any units that are breaching this thickness that we might need in order to develop a successful crown. The thickness map allows us to go ahead and view in different colors areas that are going to be successful and areas that might be of concern and areas that are probably going to be unsuccessful in their milling debuts. So normally we would have such safeguards in the milling or in the CAD software that allow us to go ahead and enforce minimum thickness and see instances where there are minimum thickness and we can adjust it there. But there's never been such a safeguard on the milling end to prevent any sort of third-party design to come into our milling software to not be able to enforce those thicknesses or see where there might be problems in those areas. So this is a good analytics tool to allow us to decide if there's going to be any sort of failures or possible failures within the unit during the milling process. And so the milling software allows us to go ahead and view those different areas based upon the coloring mapping system that you see here before us. And we can customize those individual thicknesses and the control settings of the Millbox software. So these were a few of the things that I did want to show to you. Unfortunately, I did not have I had a few technical difficulties and was unable to physically show you on the screen itself. So with that said, I guess we'll go ahead and move on. And if anybody has any questions, we can go ahead and tackle those now.
All right, let me take a look here. Do not have any questions. Just want to remind you guys, if you have any questions, use that questions tab on your control panel and you can just type one in. We can have Matt respond live. Just give it a minute.
Yeah.
Thank you, Matt.
No, I'm sorry that we went through this so fast, and you know, I really wanted to detail those aspects a little bit further with the Sum3D or the Millbox software, but you know, at least we were able to touch on them, and we can see what advantages that these bring to our dental market and to each of the labs that we have going out forward.
I'd like to thank you so much, Matt, today for your presentation, and thank you all for joining the webinar. Have a great afternoon.